So hello, everyone, and thank you for joining. Today, we're going to be talking about decrypting software patents. And so, there's software is everywhere these days, as I'm sure you've all appreciated. And so it's really key to understand how to protect software innovations and some of the implications of some of the things that are incorporated into software or how you engage different groups in your software development. So a quick note about myself. My name is Ashley Sloat. I am the president and director of patent strategy at Aurora Consulting. I've been in the patent space for about a decade now, and of course have seen many trials and tribulations, both in law and in practice. And so I'm happy to share some of those insights with you today. So again, feel free to drop any questions that you have into the Q&A spot in Zoom, and we'll address them at the end here. So software is eating the world, as Silicon Valley engineer and investor Marc Andreessen famously said. It is central to so much of today's innovation, and the growth potential is huge. So the software growth trajectory is shown here with just a few statistics that are quite mind-boggling. By 2025, the AI-powered market will grow to 180 billion. By 2022, so already next year, the global edge computing market will grow to 6.72 billion. IoT devices, about 50 billion of them will be in use worldwide by 2030, and the global AR and VR market is expected to grow to 209.2 billion by 2022. So huge amount of growth, and it's only going to get more crazy. And as you can imagine, patenting has high value. It can maximize your use of funding, help your company or your technology grow, and protect your IP from being copied. And patents are the strongest form of protection and one of the best possible returns on investment. According to a Bloomberg Law report, a patent portfolio with only one issued patent has a median price of $338,000. According to a 2012 study, software companies that IPO raise on average an extra $1.1 million in the US per each additional patent application. And according to a 2016 MIT study, which found that startup growth is 35 times higher for companies that apply for patents. So as you can see, patents have immense value. And so software is eating the world, patents have immense value. Where's the problem? Well, the problem is that, unfortunately, patenting software or protecting software is socially controversial and legally unsettled. And we're going to get into those social and legal issues here today, as well as how to protect your software innovation or options for protecting it. And from an implementation perspective, we'll look at how iterative agile methodology can impact your patent strategy, what to consider when incorporating open source software into your technology, how do you manage code ownership when outsourcing or working with dev shops, and some SaaS specific implications for protecting your software. So we'll start with the elephant in the room, or rather the troll. So the social dynamics of this space have gone on for quite a long time. So, collectively, I think everyone agrees that they have a common desire to promote software access and development. However, some believe that patents accomplish this. In exchange for your public disclosure of your technology, you get a limited monopoly of 20 years. On the other side of it, some believe that open source software accomplishes this. And, in particular, this group has been emboldened by the development of non-practicing entities, which monetize patent portfolios and seek infringement action on various companies. And so they believe that this MPE, or so-called troll problem, is the result of over-patenting of software. However, what I'm here to show you today is that I don't think that they have to live in isolation. I think we can still protect software via patents, and I think we can still use open source. And honestly, frankly, from an MPE perspective, a lot of small companies and inventors actually wouldn't ever be able to assert their technology if they didn't have the help of MPEs. And so I think, media and whatnot has kind of overblown that issue. From a legal perspective, prior to 2014, it was quite easy to patent software. It basically you would claim it as a computer implemented method, or a computer readable medium, or a system that included a computer. But since the 2014 Alice versus CLS Banks Supreme Court decision, software patenting has been made a little bit more tenuous or difficult. An additional case law has only further complicated software patenting. But what I am here to tell you is that there are definitely some tidbits that I can share with you about how you might be able to go about that even in this post-Alice age. So we're going to move into how to protect software innovations. So here's the problem. This represents data from 2014 to 2020 for the Federal Circuit. The Federal Circuit is the patent trial and appeal board. So when things are appealed from the district courts, it moves to the Federal Circuit. And then when they're appealed from the Federal Circuit, they go to the Supreme Court if they elect to pick it up. And you can see that over this time span that a significant majority of patent cases where 101 decisions were being made, that patent subject matter eligibility decisions, that a significant proportion of them were found to be ineligible. And this is what practitioners have been working on, is how to find the key aspects to make your software innovation eligible. So why do startups file patents? They stimulate investment or acquisition. They can deter patent infringement lawsuits. If you have a patent pending on something or issued, people are not sure whether, the likelihood of your asserting an infringement action against them. So they're maybe less likely to copy you. And it also helps to carve out contribution to a partnership. And we'll go into this deeper later, but we've had a lot of companies come to us recently, especially in the last year, who failed to do this early on. And so when we inherited the sins of the past, if you will, it was really hard to dig them out of this hole of how to define partnership and contribution and who should own what. So we'll talk more about that later. So the problem with software patents is that the Congress has laid out 4 categories for patenting, and those are processes, machines, manufacturers, and compositions of matter. And as you can imagine, software tends to find itself in the process and machine categories because either it's a method, a computer implemented method, or a machine, a computer that employs a method. However, the courts have long held, and Alice obviously fed into this, that there are implicit exceptions to these 4 categories. Those exceptions are laws of nature, natural phenomena, and abstract ideas. So software tends to fall into the abstract ideas category and sometimes into the laws of nature when it's a bit more mathematical oriented. In short, we like to say it's the money, math, or mental issues. So if your claims are very heavy in money, math, or mental, or viewed as such, that you're probably going to see an Alice rejection. So this is the subject matter eligibility test that the Patent Office and courts will walk through when they are determining the eligibility of your innovation for patenting. So as you recall, they're going to ask whether it's a statutory category, which is a process, machine, manufacturer, or composition of matter. If it's not one of those categories, it's not eligible. And honestly, I can't think of something that doesn't fit into that, but I guess scouring the case law would help me define that. If it is in one of those categories, then they're going to ask if it's directed to a judicial exception. If you recall, those are the laws of nature, natural phenomena, and abstract ideas. If they are not one of those exceptions, you're going to find your claims eligible. If they are, they're going to move on to the next step, which is, are they integrated into a practical application? So this can mean like a very specific device, a very specific use case, a very specific technical solution or problem. And if the answer is yes, then it's eligible. If not, then they move on to the last step, which does it have significantly more than what was currently in use or in the prior art. And if the answer is no, not eligible, and if the answer is yes, it does have significantly more, then it moves to the eligible camp. So given this context, what are some things that you shouldn't do when claiming software? And the converse of that, what are some things that you should do? So don't recite the automation of previously manual processes. The computer should not be invoked merely as a tool. You should claim with specificity what the software does. This is exemplified by this ineligible by Safe v. Google court case. This patent application was filed and prosecuted before the Alice decision, so they might have pursued different claims had the case law had the interpretation it did at the time they were going through prosecution. So that's some of the difficulty with changing interpretation of laws, is that as a practitioner, you kind of have to crystal ball it when you draft to try to see how the laws might be interpreted differently over time so that you can account for those changes. So this patent was owned by BuySafe, and it claimed methods in machine readable media to perform steps for guaranteeing a party's performance of its online transaction. In 2011, BuySafe sued Google in the District of Delaware, alleging that Google infringes these various claims. Google moved for judgment on the pleadings, arguing that the asserted claims were invalid under subject matter eligibility guidelines, or Section 101. So you can see here that the method is very general. It really is, there's nothing really computer specific about the claims. I mean, they do say at least one computer application program running on a computer, but otherwise all the language here is, something that you would use to talk about doing this in a manual way, right? A first party for obtaining a transaction performance guarantee to an online transaction, request by underwriting the first party in order to provide the transaction performance guarantee to the service, and then the transaction performance guarantee service that binds the transaction performance guarantee to the online commercial transaction. So clearly, I mean, the court viewed this as the computer being merely invoked as a tool. The application also describes things like an authentication key generator, an applicant validation mechanism, individual and benchmark ratings, and a guarantee seal generation mechanism. These are things that are clearly computer specific and would have helped probably their case. And so again, had this been filed, prosecuted after Alice, they might have pursued different claims. So these were found ineligible. Don't claim just the output or intended goal, claim the process through which the goal is achieved. So this is probably one of my favorite eligible cases. This is DDR Holdings versus Hotels.com. The claims address the problem of retaining website visitors that, if adhering to the routine conventional functioning of Internet Hyperlink Protocol, would be instantaneously transported away from a host website after clicking on an advertisement and activating a hyperlink. If you think that this doesn't exist in a manual way, right? If I go into Costco and go to a kiosk, I don't get automatically transported to Meijer, right? So instead, the patent claims call for an outsourced provider, which directs the visitor to an automatically generated hybrid web page that combines visual look and feel elements from the host website. So the claims addressed a specific internet age problem, not a longstanding business practice, and provided a specific technical solution. So you can see the green language here that I've highlighted. It clearly is very specifically computer implemented. You have capturing a look and feel description, storing HTML code, providing the host website with a link for inclusion within a page. Upon receiving activation of the provided link, serving to the visitor computer from the second website page with a look and feel corresponding to the look and feel description of the host website, such that the user perceives the page as associated with the host website, even though it is served from the second website. So again, very specific computer technology, very much towards the internet age, and they had a lot of great description in their patent application, which described what a look and feel meant and these processes. So this was found to be eligible, again, for that particularity. And then what not to do when claiming software, again, don't claim it in such a way that it could be performed in the mind. Claim a technical solution for a technical problem. So this is Ancora Text versus HTC America. Note that this patent dates back to 1998, so it may seem obvious today, but this was quite new back in 1998. So you can't use your hindsight bias. Methods of limiting a computer's running of software not authorized for that computer to run is what the claims enclosed. So the claims are directed to an improvement in computer functionality. The courts love that. If you can tie it to an improvement in computer functionality, it's going to be very easily found to be eligible. Or again, a technical solution for a technical problem, which this also satisfies. So you can see that, very computer specific language. They're talking about selecting a program in volatile memory, using an agent to set up a verification structure in the memory, verifying the program using the verification structure, and acting on the program according to the verification. So a great technical solution for a technical problem, namely the vulnerability of license authorization software to hacking. So what to do when claiming software, we already kind of went through these, but this is kind of said another way or some additional tidbits. Claim features that contribute to an identified technological improvement, whether in the actual computer functioning itself or other technological improvements relevant for your art or your technology area. Integrate any abstract ideas into practical applications of the software, and recite with particularity features of the solution or the improvement. So a few additional case law here. So this was found eligible for a technological improvement. This was Enfish v. Microsoft. The EnFish was basically claiming an improvement to database systems memory configuration. So a specific improvement to computer functionality rather than abstract ideas where computers are merely invoked as a tool. So you can see very specifically that they talk about the database architecture, logical rows corresponding to a record of information, logical columns having an OID to identify each column, and then wherein the logical rows have an OID equal to the OID of a corresponding column. And at least one of the rows includes the logical column information defining each of said columns. And so this is really a self-referential table and was found to be patent eligible. Then eligible for integrating into a practical application. This claimed a device for protecting and reporting the presence of atrial fibrillation or atrial flutter in a patient. You can see that they incorporate a beat detector and a ventricular beat detector. So a specific device, very clearly a practical application. And then they have the logic behind how fibrillation or flutter is determined in a patient. And then lastly, I know you all are loving this case law stuff. Specificity of a solution. We can look at Macro v. Sony. These are methods for automatically animating 3D characters' lip synchronization and facial expressions. So these were found patent eligible because they were a specific method of improving computer technology. So it's not specifically the computer itself, but computer technology for lip synchronization, and relied upon their particular technologies to make those improvements. So you can see, again, it does recite just a generic computer, but then they have very specific rule sets that the computer employs to set up this lip synchronization protocol. And so again, a very specific, technical solution, very, very specific. So other requirements for patentability: novelty. No one reference discloses all the claimed features. That means references include patent applications and patents, literature, websites, trade shows, dissertations, and in the case of software, can even be code that ends up in a public repository. So make sure that when you are using repositories, that you are using private repositories, because you can kind of create problems for yourself. Obviousness or inventive step is no one or more references explicitly or inherently disclose all the features. So this usually looks like the examiner saying this one reference, if modified by one of skill in the art, could arrive at the invention as claimed, or these two or more references collectively disclose all the features in the claims. Now note that there are a lot of legal exercises that we can go through to overcome an inventive step or obviousness argument. So it's not as simple as just combining some references. Sufficiency: does the patent disclosure reasonably convey to those skilled in the art that the inventor had possession of the claimed subject matter as of the filing date? So it seems a little crazy, but obviously if you don't describe something in great detail, how does the patent office know that you actually had the invention, right? That you knew how to make and use it. So you have to put enough detail in there so that somebody else can pick it up and make and use the invention. Enablement is the invention described in such a way that allows one skilled in the art to make and use the invention without undue experimentation. So again, you have to describe it in great detail so somebody else can make and use it. The undue experimentation is particularly important in the chemical arts and biotech, where those are highly unpredictable sciences, and software should be pretty easy to enable your disclosure so that it doesn't, is implementable with just routine experimentation. And then lastly, best mode. The patent app sets forth the best mode contemplated by the inventor. So again, you can't keep the best mode for yourself. You do have to disclose that, but you do not have to label it as the best mode. For AI and ML innovations, these typically fall into one of three camps. You have applied AI, core AI, and hardware. So applied AI is the invention is really only possible because of the machine learning or the AI that was employed. For example, if you're trying to make it faster, easier for images from a medical standpoint to be reviewed and assessed, using routine ML or AI to do that would be considered an application of AI. Improve or automate known processes. Again, that kind of similar example works. And then the main invention is not ML. In other words, you're basically just using ML as a tool. You're not creating new ML or changing the ML that's currently available. For core AI, you are literally changing the underlying AI to make it used for your purpose. So that means that maybe you're processing the training data in a different way to make it consumable by your AI. You're maybe modifying training methods to get the AI to work with the data set that you're working on, or maybe even improving the models, adding layers, changing the layers, and things of that nature. For hardware, in this IoT age, AI is AI is being adapted for particular hardware configurations, especially when the devices are getting smaller and smaller and smaller. It does require that AI be further adapted for those hardware specific requirements. Additional IP considerations for software: consider design patents for ornamental aspects like animations and GUIs or graphical user interfaces. Consider trademarks for slogans, brand names, logos, sounds, or even colors. Consider trade secret for innovations that are not patent eligible, not ready for patenting, or more valuable as a secret. Do note, though, that if you have trade secreted software that's not ready for patenting, you cannot sell and disclose that software still, even if it's trade secreted, because you cannot keep something secret and still sell and publicly disclose it and essentially elongate your patent monopoly. So you do have to either keep it internally secret until it's ready for patenting, or you shouldn't be using the trade secret from a public perspective if your intent is to later patent it. And then copyright for unique software code expressions. Let's dive a little deeper into that. So software patents versus code copyrights. Copyright protects the literal expression or the source code of an idea or derivations of that, and guards against exact replication, like I said, or derivations of that. Patents protect the idea and the functionality implemented by the source code, and that's regardless of the language used, how they've implemented it, whether they used open source or not, or their own custom solution. It's not the literal expression, it's the overall idea. So patents can be really powerful in that regard, because as we all know, 10 different software engineers could write 10 different programs to perform the same function. And so patents can be really valuable to that end. So lastly, we're going to talk about implementation concerns and strategies. We're going to briefly look at agile methodology, open source use, outsourcing, and SaaS implications. Each one of these honestly could be its own talk, but there are some particular sharp corners I want you to be aware of, and we'll go through today. So agile is a constant state of evolution. So how do you incorporate identification of innovations into your software development lifecycle? So software has largely transitioned from a traditional waterfall practice where things are just thrown over the wall and years later you arrive at a product regardless of how the world has changed since then. And now we're moving into a full embrace of agile methodologies with the goals of higher quality software. And so it's all about producing more valuable output for the customer at a faster velocity. And the more value being that, more input throughout the dev cycle rather than this just throw it over the wall and see what comes out. Depending on the study, somewhere between 70 and 80% of companies surveyed are using some form of agile methodology. But most of the things that make agile great complicate matters when it comes to traditional IP, like invention disclosure and capture, and basically creates a more rapid turnaround for that. So they have fast-paced work cycles and rapidly evolving objectives. So it's difficult to sync IP capture and strategy with these high-paced, short time sprints. So it requires, more frequent check-ins or more involvement for your IP professional. They have stringent resource optimization. Developers are fully utilized on sprint completion, and so patenting becomes an afterthought. And this is honestly a problem that transcends all fields where, you were hired to do a job, and the job is develop software, make a medical device, figure out a chemical composition. And so you really do need a professional that's going to be embedded into your processes and doesn't require your people to be taken off the prize or the goal of the prize, which is that end product. Incremental completion with continuous delivery of smaller portions. It's hard to know where there's enough to protect. So you have to be able to see the forest for the trees. And so knowing what the end result is going to be. And so because that needs to kind of be the overarching message, right? That this is the goal, this is the technical solution. And then lastly, early disclosure, I guess not last, I think I have one more here. Early disclosure and customer feedback. During the potentially many user research and review phases, you may be disclosing products under development to potential external customers for their feedback. This presents a major risk in terms of public disclosure. When you're pushing that out, it has to be, you could use an experimental use exception, right? That you're clearly using it just to get feedback. That's experimental in nature. You're maintaining control. And if you don't do those things or do non-disclosure agreements, you could be opening yourself up to an early public disclosure event that hinders your ability to patent it later. And then self-censorship. Again, this is something that transcends all fields. It is so easy for inventors to say, well, that was just an easy thing. It's like no big deal. But those details can be really the difference between subject matter eligibility and not, or the difference between a technical solution for a technical problem and not. So really, try not to lose focus of the bigger goals, and, definitely don't be afraid to involve your practitioner in all these little details. You may be surprised what they pull out from a value perspective. This is agile software. This is one example of an agile methodology. So you can see here, we start with requirements and user input. So this is basically what product are you going to build? What are the key features? What drives customer adoption? And then the planning phase, the stakeholders decide the new features and changes to the existing features. And then they go through a development phase or sprint where the development team works to code, test, and debug the one or more features agreed upon during the planning phase. You may enter a user review phase where the development team demonstrates the software and its newly implemented features, either internally or externally. And if it's externally, there's some considerations there that we'll discuss. And then retrospective phase, the development team reflects on the last iteration and discusses items that worked and didn't. And note that ultimately the goal is to release the software. And so there's some considerations around IP there. And so some basic places where I would consider there to be likely IP is during that planning phase when you're kind of defining what the forests are and what some of the trees are. What are potentially some patent eligible features? Of course, after the development sprint, when there have actually been implementations, probably some technical solutions for various problems that were encountered, probably some IP there. After user review and or before release, there's definitely some, potential for intellectual property there. Actually, let me back up for a second. In this one shown here, you also want to consider doing any filings before user review, again, to avoid any public disclosure issues as you push the different things out to users for review. And now, again, there's a difference between internal and external. If it's external users, you definitely want to consider whether any IP should be filed. And then before release, if you have something that is patent eligible, I definitely would consider doing it before release. So again, because your release will trigger a public disclosure event. So matching Agile's rhythm for filing. So provisional patent applications can be a great tool for mirroring Agile's iterative approach. You can file a series of provisionals as the product evolves through the sprints, with details getting tacked on iteratively in subsequent provisionals. So know that these are not all just one separate provisional. It's likely a provisional that grew over time. Within a year, this process is followed by at least one non-provisional that claims priority to one or more of the provisionals. So you get the benefit of the low-cost, lower fidelity provisionals that secure the filing date and a guard against public disclosure while giving you enough time to prepare a non-provisional that is more robust and Alice-proof. And so note that, so again, you're claiming priority to one or more provisionals. And if at some point you decide that a provisional either doesn't fit the current narrative, that wasn't actually in the current product, because again, during those development cycles of sprints, you may find that a feature that was currently desired is no longer desired. So, and that may be what that provisional covers. So you can abandon that provisional and it just disappears. If nothing claims priority to it, if no utility claims priority to it, it just disappears. You can also refile the provisional you can also refile the provisional and it will get a new filing date. And so that's that refile provisional, that can extend your 1 year timeline. But again, you do lose that early filing date. So if you've had public disclosure events during that time frame, that may cause problems for that refiled provisional. So how do you protect your IP while conducting user research and reviews? It is good to have non-disclosure agreements, even if it is called a product advisor agreement. So an NDA with a feedback clause is even better. A simple example of such a clause is what's on the slide here. It basically says that the company is free to use and incorporate the feedback without any payment, and that the company owns it, assuming that it does not infringe any customer's IP rights that existed prior to the feedback being given. And so, it's good to include NDA language, at any possible point. A lot of investors won't prescribe to NDA language, but I'm sure different customer feedback and things like that can be part of your user agreement that's included in your software release. So what are some open source software considerations? Use of open source software is an incredible accelerant toward building your product. So why reinvent the wheels, right, when somebody has already created great solutions? And depending on resources and budget, sometimes open source software is the only practical way. But this is a very complex domain, chock full of gray area. And there's actually not a lot of court opinions that I could show you, bore you with today, that have weighed in on this topic. So it always comes with some level of business risk. It's highly dependent on license type, what you're doing with it, how you're calling it, and how it's being distributed. It's worthy of its own deep dive, but we'll hit on some of the highlights here. So open source software licenses are primarily royalty-free copyright licenses, granting third parties, i.e. you, the right to copy, modify, and distribute the computer code, of course, with strings attached. And each license has its own strings that it comes with. The worst offender that should flash all kinds of danger signs for you are considered copyleft. One example is the new general public license, or GPL. Copyright licenses require derivative works, in other words, your software that includes the open source, to distribute using the same terms as the open source you just included. Practically speaking, this license infects your linked software, requiring you to release your proprietary creation as open source, giving the public domain the right to copy, modify, merge, publish, distribute, sublicense, or sell copies of it, regardless of whether you have a patent on it or not. So if you use GPL open source, your software will become GPL open source. Some of these things are less of a concern with more permissive licenses like Apache and MIT. There's also a version of the GPL called the lesser GPL that does not have the same infectious property. So open source and patents. So OSS can be patented and often is patented. So usually it's an extension of that open source though, right? It's not like because open source, by virtue of it being public, is considered a prior art reference, right? So it could be used as a rejection. So typically you're using it by building upon it for a new outcome, a new technology. So it's often patented for offensive, defensive, altruistic, and commercial reasons. For example, defensively, it can be used against someone else patenting the same functionality and asserting the patent against the OSS, the open source. Offensively, it can be used to prevent someone from replicating the functionality of the open source and licensing it under a proprietary license. It can also give options for author to generate revenue from users who don't want to be bound by the license, all without hindering open source innovation. There are also express and implied license grants, which extend a license to you from the original developer of the open source, enabling infringement-free use of patented aspects. Many of the more permissive licenses like Apache include license grants. And then the patent retaliation clause impose penalties, for example, license termination, if you attempt to assert infringement claims related to the use of the OSS. But again, this shouldn't be an issue because you should be using the OSS as a part of your software, and it shouldn't be the main crux of your software, because then it shouldn't be patentable because the prior art is the open source software. So outsourcing and code ownership, again, this is like a heavy topic. So we've seen a lot of no-nos, faux pas, however you want to call it this year. And so I don't know if it was something in the water, but we've seen a lot of clients come to us ready to convert and have significant issues. So you may find yourself in a situation where you need to outsource your software development. And then, of course, 43% of companies do this. It's a very common practice for startups because that basically comes, you don't have to hire a full-time developer. You can just outsource it to a group. But how do you share the necessary confidential information and ensure that you actually own the produced intellectual property? So before entering into any sort of partnership, it's very important to establish clear lines of ownership around IP. And that kind of harkens back to my earlier slide that said, you need to carve out a contribution to a partnership using patents or other intellectual property. So we'll talk a lot more about this in our next installment of the Spark series in December, but we wanted to hit on it here because it's highly related to this topic. So it's important to know that obviously there's the three circles here shown, the Venn diagram with your product in the middle. There's existing code created by the dev shop that's already used as generic libraries in other customer projects, but they also may develop code that they want to keep in your libraries for your project. And so it's that new code that's being generated that they may want to keep in their libraries that is negotiable, right? That you can maybe own that new code as well. There's existing open source code that you have to maintain compliance with. And so you don't have exclusive control over it. And there's obviously the new code that you can control and have proprietary use over. And that's what we'll be focusing on here, is that new code, this bottom bubble here. So you want to ensure confidentiality of all IP assets, trade secrets, and information you need to share through a non-disclosure agreement or an NDA with the software development partner. All good contracts should have some sort of non-disclosure provision in them that protects you. Also try to avoid IP rights traps. So if I pay for development, will I own the code? Shockingly, not necessarily. So the software development agreement should explicitly provide for your ownership of any IP that is created during the execution of the contract. Absent express language or conveying an assignment, the software development agreement does not imply a transfer of rights. You need to have an assignment clause in there that the development company agrees to assign or hereby assigns or has an obligation to assign the IP to the paying company. And then the big copyright gotcha is that under copyright law, literally the person who puts their fingers on the keyboard and types out a line of software is the author and owns the copyright. There's a work made for hire rule that makes it so the business that hires the employee who typed the code owns the code. But this breaks down if you're hiring a contractor, which is very common, especially in this gig economy. The third category is the gotcha, this contractor gig economy scenario. A commissioned and copyrightable work will only be considered work made for hire owned by the requesting company as long as there is a written agreement. So again, you should have an assignment clause, a non-disclosure clause, and a work made for hire clause. This is blocked acquisitions when the purchasing company has discovered that the company that they were looking to purchase actually didn't control or own its code. And also remember the OSS license implications that apply to the code and how they factor into all these agreements. And make sure too, I guess the other part is make sure that internally and anything shared with external vendors that you have very clear parameters around what you accept as open source use. You want to be very clear that you not only here's your provisions around how open source should be used, but that they need to disclose all the open source that they have used. So you have full view into all the liability that may be in that code base that should be maintained under your control too. Make sure that you have ultimate control. You have all the passwords, usernames, and everything that's not in their code repository, that's your own private repository. So protecting your SaaS, some key notes here. The value importance is that in the SaaS world, many real assets like inventory, physical property, and hardware are contracted out and or virtualized. Patents may be one of the few real assets a SaaS company has on its books. So rights transfer, SaaS agreements specifically SaaS agreements specify features offered through the service. It's important to protect your IP rights in the agreement to prevent transfer of ownership and limit use of your rights. Typically comes from the form of a provision indicating that the customer is being granted a license to the IPRs for use, but that the ownership of the software, documentation, and other IP remains that of the provider. Jurisdictional scope. Remember that patents are a country by country right. Even for Europe, you go into Europe as one huge jurisdiction, but then you select countries at the end of it. And so many SaaS products are cloud-based offerings. Cloud-based products are often operated on infrastructure that could have hardware, data, and services distributed across international borders. So when it comes to enforcement around infringement, there can be uncertainty over these jurisdictional scope, since the invention may reside on servers physically located outside of an enforceable jurisdiction. So when it comes to SaaS products, it's very important to hone your strategy around filing. Consider what the server is actually doing, what a user computer is actually doing, what a wearable is doing, and maybe try to have claims in those specific countries for each of those specific feature sets or methods that are being employed. And then extra OSS flexibility. A lot of SaaS offerings come via web apps, and web apps are accessed via a network, which under some OSS licenses doesn't constitute distribution and opens up some more flexibility. So again, if you take away nothing from this talk, really consider, really reading and understanding your open source licenses that are, don't click it like a user agreement and never read it. Actually read your open source license and make sure you fully understand the metes and bounds of it. So lastly, some key takeaways. When you're developing software or lean heavily on your patent practitioner for this, Look to identify technical solutions for technical problems and do not self-censor. You'd be surprised what could count into this technical solution. Consider a comprehensive approach for your IP. Don't dismiss trade secrets, design patents, trademarks, copyright. Consider it all. Match a nimble IP approach to your agile development workflow. So again, lean heavily on your IP practitioner and really look at the product as a whole, but also what's happening during each development sprint. When using open source, understand the license implications. Please read your open source software license and make sure you understand all the provisions and have it cataloged somewhere, even like in notes in a code database. Avoid IP rights traps and the big copyright gotcha. Include non-disclosure language, assignment provisions, and work made for hire provisions in all your contracts. Do not let anybody do anything for you until they have signed a contract with you. And honestly, gotten a 1099 from them too, a W-9. And then protect IP rights and hone your international strategy for SaaS products in particular. But this also goes to all software, which may be distributed in some sense. So with that, I think we have about 15 minutes for questions. And if you can't think of anything now, but you think of some later, please feel free to email me. And also note that we do have a podcast where we do talk about a lot of these topics that are evergreen, but some that are also hot topics. And so if you love listening to IP strategy on your commute, please let us know, or please take a look at that podcast and you can get some valuable insights. So we have one question here from Dave G. Would you comment on process of approving infringement for software patents? So that's a great question. So really it's going to come down to discovery ultimately, but you would have to, again, software patents are a little bit easier in the sense that the software just has to execute a certain set of method steps, right? And so it doesn't really matter how they implement it, but if the software goes through X steps that are covered by your patent, you have a reasonable, you can reasonably infer that they're maybe executing a similar method. And so then during the discovery phase of an infringement proceeding, you could actually prove infringement at that time. So, at the time of making an infringement declaration, you're going to have to be able to tie functions of their software to your claims. So if anything, I would personally consider doing some kind of claim chart where you have your claims and then their product and how you believe their product ties to your claims. Any other questions? Otherwise, I'm sure I could find more case law for you all. A follow-up from Dave. Any comment on risk of filing software patents that is rejected becoming public domain? That is definitely the case. But if you have, I think I would say, if it's drafted well, that being a big asterisk, but it's drafted well, I think you have a lot, so it's not, I don't mean to scare anybody. It's actually not that hard to patent software these days. I mean, there are definitely some hard ones, but if you draft it well, there's not a lot of risk. But if you don't want it to become public and you don't have any foreign filing interest, you can do a non-publication request. So that means you could prosecute it all the way up until allowance or complete rejection. And then you could, remove the non-publication request and allow it to pass to issue, or you leave the non-publication request on and it just goes abandoned. But that means that you do not have any foreign filing interest. So a non-publication request is a great strategy tool if you don't have any foreign filing aspirations.
All right, Ashley, I'm not seeing any more questions.
I appreciate it, everybody. Thanks for coming out today. And like I said, if you come up with a question later or after you get the materials and you've had some time to ponder, and like I said, I know it was kind of drinking from a fire hose today, but please feel free to reach out and happy to give you a tailored answer through email. So just let us know.
Thanks, Ashley. Thanks, everyone, for coming.
Take care, everyone.
Have a great day.